Hey there, coders. Welcome back to another exciting episode in our Rust programming series. Today, we are diving deeper into threats in Rust. To put it simply, a threat is like a contract. It defines a set of methods that a type must implement to meet that contract. Think of it as saying, if you implement this threat, I expect you to behave in a certain way. However, unlike interfaces in languages like Java or C Sharp, Rust thread allow default implementation. This means you can provide a default behavior that type can either use directly or override with their custom implementation. Now let's see. We will start by defining a simple trait called overview. This trait has one method, overview, which provides a summary of an object. Here is the code. Let's start. Let's start trait, name it overview. Let's create one function overview, not this overview, and take it as self, which return string, and give, let's say, hello from devstream. Here, trait overview. This defines a new trait named overview. The function fn overview and self, a method signature that any type implementing this trait must use this function. Now and self takes a reference to the self and return a string. Default implementation. Rust allows you to provide default behavior for trait methods. Here overview. Here overview returns the string hello from devstream for trait. Any type implementing this trait can use this implementation without defining its own. This is one of the Rust standards feature. You get the flexibility of interface with the added convenience of default method. Now let's see struct that use the trait. Next, let's define struct struct. Let's say course. I will use course. Let's say course name, which is string, and let's say author, which is also string. Let's create one more struct. Let's say it another course. Name and author. Close that. Now, course and another course are simple data structure with field, name, and author. We will use this struct to demonstrate how traits can be implemented differently for different types. Now implement with trait. Let's see impl overview for course. Now we must have to define this function for course. Now let's define fn overview and format is self.name and this. Here impl overview for course. This tells Rust that course struct implements the overview trait, and fn overview and self overrides the default implementation of overview, override of this implementation, and format. uses the format macro to create a custom string, means self.name, where we print the author name, where we print the course name, and by author name. Now for another courses, implement one more. Implement another course. Now in the main function, let's create course1 equals course course, and let's say name is Rust programming, author is devstream. Let's create one more course, let course2, and not Rust programming, it's Java programming, and author is devstream. Now print overview, print for course1 and course2. Sorry, let's see the output. Rust programming for by devstream, Java programming by devstream. Now let's see how it worked. We have created instance for course1 and for course2. Course1 is an instance of course with a specific name, and author. Course2 is an instance of another course. Now we are calling course1.overview, call the custom implementation provided by course here, custom implementation. And course2.overview calls the default. If we remove this, let me remove this for implementation, it will call the default implementation. Now if we print hello from the devstream, it will call the default implementation because we have not defined here overview. Now course uses its custom overviews. That's why it printed Rust programming by devstream, and another course falls back to default implementation. That's why it has printed hello from devstream. Now that we have seen how threads works, let's discuss why they are so useful. First, for its flexibility. Threads allow you to define behavior once and apply it across multiple types. Second, code reusability. Default implementation reduces duplication. Third, safety. Threads enforce a contract ensuring all types meet the required behavior. Fourth is generics. Threads make generics even more powerful by enabling you constraint type. Now, real world application of threads. In real world application, threads are everywhere. For example, built-in test, custom behavior, polymorphism, and many more. That's all for this video. I will see you in next one. Thank you.